Hello everyone, welcome back. So today we are going to start with convex mirror ray diagrams. So make sure that the rules are thoroughly learned before watching this video. So in this case we have only two object positions. The first one is object at infinity. So the same we have done for concave mirror also. Here also the diagram remain the same, but the only change is the mirror. So there we have used concave mirror, here we are using convex mirror. So draw the convex mirror, label all the points on the principal axis. So one important thing that you have to remember here is the reflecting surface. So the thick line is the reflecting surface of the mirror and it should face towards your left. So you have to label your P, F and C. So as I told you in the previous video, since the object is at infinity, here we are not showing the object position, we use parallel rays of light. So here you can use two rays. One is above the principal axis. So again this is rule 1, parallel to principal axis. Then what happens? It reflects and appear to reflected from or appear to diverge from the principal focus, because convex mirror is a diverging mirror. So the rays after reflection they diverge. So the green line shows the reflected ray. So parallel, reflect, but it appear to reflect from principal focus. Now I am using one more ray which is below the principal axis. Then again parallel, reflects and appear to reflect from the principal focus. Why we are using two rays? Because you will get the image only when rays meet or appear to diverge. So here we can see that they are appear to diverge from the principal focus. So what are the image characteristics? Yes, here the image formed is virtual and erect. Why it is virtual and erect? Because it is formed behind the mirror. So here rays appear to diverge from behind the mirror, therefore we call it as virtual and erect. And the image is point sized, or you can say highly diminished. And where is the position of the image? Image is formed behind the mirror, that is at focus. At focus behind the mirror. So the same thing is applicable for concave also. For parallel rays you are getting at focus, but in that case the focus is in front of the mirror, but in this case the focus is behind the mirror. Now let's move on. Here we have only two object position, one is at infinity, the other one is between infinity and pole. So again draw the mirror, principal axis, mark pole, focus and C. Label the point P, F and C. So again I'm placing the object because it is between infinity and pole. So you can place object anywhere on this axis, okay, because it is only between infinity. So infinity and pole we can place anywhere on this axis. So I have placed here. Now I am applying rule 1. This is rule 1, parallel to principal axis. What happens? It gets reflected and it appears to diverge from principal focus. This is the first rule. Now I am using rule 4 here, that is the ray hits the pole obliquely and reflect obliquely by making same angle of incidence and reflection. Now see, both these green shows the diverging rays or reflected rays. Okay, this green shows the reflected rays. These reflected rays are diverging, so they will never meet. So what you have to do? You have to extend backward. So the rays are diverging from this point. So you will get your image here. Again you are getting the image behind the mirror. Since the image is formed behind the mirror, I have used dotted lines. So dotted lines indicates the image formed is virtual and erect. Now let's see the characteristics. So these are the characteristics of the image formed. Nature is virtual and erect because it is formed behind the mirror. So all virtual and erect image must be represented using dotted line with upward arrow. And what about the size of the image? Diminished. So you compare it with the object size. You will see that it is small. Small means diminished. Now where are you getting the image? Behind the mirror, and mention the position between F and P. So you are getting the image between F and P. So these are the two object positions for convex mirror. Now what are the real life applications or real life uses of this object? This mirror. What are the real life applications of convex mirror? First one is it is used as rear view mirror. Rear view mirror in vehicles. So the side mirror of car or side mirror of vehicles you can see. That is convex mirror. Why convex mirror is used? Because it can form virtual and erect and diminished images so that it can cover large area, large field view. Okay, and it is also used as security mirror. In shops you can see the security mirror, and also in parking lots, parking areas you can see the mirror. That is, all these are security mirrors. So these are the applications of convex mirror. So we have completed our ray diagrams for concave as well as convex mirror. So if you have any doubts or if you have any questions, don't hesitate to post it on comment box. I will be replying to your doubts. So thank you. Have a nice day.